Hi, Dr. Rick Weibel. In this chapter, we're going to talk about Chapter 6, Data Communication. Data communication includes not just communications between computers, but even things like communication between your keyboard and your motherboard. When you press a key on the keyboard, it has an address associated with it. It sends a signal to the motherboard. The motherboard looks up a keyboard layout table that indicates that that particular key is associated with a particular character. So when you press the A key, for example, it says, oh, that's an A in the standard American keyboard layout. An interesting sidelight, I guess, is the QWERTY keyboard, the QWERTY keyboard, which is so named because of the letters right below the numbers, the top row of letters, was designed for use on a typewriter and is specifically designed to slow you down so that you do not type very fast. The problem with typewriters was that the first typewriters had little characters on the end of an arm that when you pressed the key, the arm swung up and hit the ribbon and printed the character. And so if you typed too fast, you could jam multiple little arms or fingers together, which was fun to do when I was a kid. Okay, so there are other keyboard layouts which you could learn which are faster. Because let's face it, the A key and the S key, which are frequently used letters in our English language, are placed under the weakest fingers on your left hand. Probably not the best place. Okay, back to data communications. Also, whenever you transfer data from the motherboard to the monitor or the printer, that is also a form of data communications. Not just making a request for a new web page using your browser, but that also is a form of data communications. Now you need to understand the basics of these things. So as a manager, you can, number one, not sound like you're ignorant and don't know what you're talking about, but so that you can know their capabilities and how they impact you and your employees in your organization. Okay, some basic components are bandwidth. We measure bandwidth, which is the amount of data that can be transferred during a certain time period, with two different characteristics. One is called the baud rate, B-A-U-D, and the baud rate is a measurement of the capabilities of the network media, the kind of cables or fiber optics or wireless connection that you're using. The other measure is called bit rate, and the bit rate is the number of bits per second that you can send. Now you say, well, wouldn't these be the same? Well, using techniques to squeeze more information together, we can take each cycle, each signal that we send, and code it so that it represents as much as 16 bits of data, so that each bit could send not just one bit but 16 bits if we properly code it. And if you take other courses, you might, or look online, you could learn all about that. Another big word, attenuation. This is that as you get farther and farther from a source, the power of that signal decreases. So as you're standing farther and farther away from a person, for example, and they talk to you, their voice gets softer and softer because the distance weakens the signal strength. So that happens if you're driving your car and listening to your favorite radio station, or in any electric signal being sent through the air or across the wire. Okay, broadband is just the way that we send information, and you see here multiple pieces are sent simultaneously, where narrowband we don't send as much at the same time. Now we have protocols. We talked about those in the last lecture, chapter 5. We mentioned these. Read about them in this chapter because protocols are very important as they govern the rules of data communication. So for example, you're talking to someone and you don't understand what they've just said. The protocol that we use in life is to ask them to repeat it. Well, we use similar kinds of things in data communications, and so error detection governs that. Protocols tell you what kind of error detection is going to be used, also how long the message is, etc. Okay, types of media. We divide transmission media into conducted or wired media and to radiated or wireless media. Wired media includes electrical conductors, so this is generally copper wire. We use twisted pairs, and so here the protocols here are STP and UDP. And we also use coaxial cable. This is the type of cable that is used with cable TV. You have the hardcore piece of copper in the middle, some insulation, and an aluminum mesh around the outside. And there's some specific reasons why we both twist pairs of wires and why coaxial is designed the way it is. The other type is a light conductor, primarily fiber optics here, although we can use mirrors and prisms if we have nothing that's going to block our light as it flows. The thing about fiber optics is they allow us to bend the light and send it around a corner without the use of a prism or some other reflector like a mirror. Okay, you're familiar with wireless as well. We have cell phones, Wi-Fi, etc. So these devices usually have a radio frequency, unless we're talking about light again, and the radio frequencies are governed by the Federal Communications Commission, the FCC, and they're divided into a number of different broad categories. There is a question about satellite communication using microwave, so you might want to look at that in the text. Okay, your remote control on your TV use infrared light to send signals. So think of the colors on the rainbow. Infrared is just beyond the visible spectrum, meaning our eyes can't see those colors. Okay. Data communications is built on a model. The mother of modern communications is the Open Systems Interconnection Model, or OSI. I always get this part confused because the OSI was created by the ISO, which is the International Standards Organization. Fun. I don't remember what the name of that backwards thing is, but there's an angiogram or something. Okay, the OSI model has 7 layers. Here are those layers. Now there are multiple questions on the quiz about these layers, specifically asking you what each layer does, so I would spend some time studying those. We have a number of different broad categories that we use when we talk about different types of networks. So we have local area networks, or LANs, metropolitan area networks, or MANs, and then wide area networks, or WANs. Now, network topologies, this is what the physical layout of the network looks like. The most common one actually is the bus, which is kind of like thinking about a bus route. So you get on the bus and it has a specific course that it follows and takes you to some other location. That's how most communications inside of a motherboard work, and also the most fundamental of network communications occur on a bus type topology. When we look at them, though, they often look like a star because we have a device like your wireless router at home with multiple plugs in the back, and so we can run several wires to your router, and it acts as what we call a switch at that point, and does the connecting using bus topology. The mesh is something kind of new and interesting. It's the ability to, as you think about maybe a piece of window screen, you think of it as a mesh. So multiple interconnections so that we can connect in all kinds of ways. And we're seeing some new things happening in mesh computing as well, trying to take a really complex problem that needs supercomputer power and spread it across several PCs so that in combination we get the same computing capability as a supercomputer, but we don't have to invest in the big resource. Okay, a couple other things we've already talked about. Protocols. The internet uses TCP/IP protocol. We mentioned that in the last chapter, and there is a question on TCP. A routing, in the study guide I say paths. The routing is a path that a communication takes. So as it goes from one device to the next device and is relayed on, then the path it takes across the network is routed, and so routers do the routing. As we said, protocols are agreed on methods. So these are rules that electronic devices use to exchange information. TCP/IP, Transmission Control Protocol, and Internet Protocol are the ones that we use on the internet. And these have pretty much become the de facto model of communications today. Now, a few specialized proprietary setups do something different, but most of the time TCP/IP is the way communications are handled. Okay, routing. Routers divide information into packets or pieces that are of a certain length, and they add addressing information and error correction information and so on. And so a packet is then routed from one device to another. So here another concept is when we connect to a web server, behind the scenes there may be multiple tiers of activity that occur. So the web browser connects to a web server. So let's say you go to Amazon, and so you go to Amazon, the web server sends you the basic home page, and you say, well, I want to search for a book, and so you send that request to the web server. It sends it to some back-end processors, and so let's say this is the book search server, and it goes to a database and looks for your book and finds the various information about the book and hands it back to the web server, which turns it into a web page and sends it back to you. Then you say, oh, I want to buy this book, and so then you're sent to another server which handles the sales transaction, and then it may say, okay, I need your payment information, and another server handles that, and then that server may go back to somebody else, let's say your bank or PayPal, and say, oh, can you handle this transaction? And they say yes, and it comes back, and then it says yes, we can conclude the sale. So lots of different things happen behind the scenes in different layers, which we call tiers. So that's what an N tier just means, more than one. Can be 2, 3, 4, 5. 3 is the most common. Okay. Virtually everyone has a cell phone, which is a mobile network, and pretty much everyone's familiar with the wireless networks as well, all across campus. In most locations you can connect to Wi-Fi. Um, oops. All of this stuff uses different radio frequencies again, and those radio frequencies are controlled by the FCC. Now with the mobile network, the geographic area is divided into a number of cells, and more or less in the center of each one of those cells is a base station. And so as you travel from one location to another, you're handed off from one cell to the next, so from one base station to the next base station, and all of that is done by software behind the scenes seamlessly. Today we're seeing convergence, where we're taking voice, video, and data, and we're sending it all across a single network. So in the past you would have a wire running to your telephone, and a coaxial cable running to your TV, and then often a Cat5 cable, a network cable running to your computer. Well, today we're doing it all across one cable. So we're using the network to control all of this. So if you have voice over IP telephone from suddenly the name of the big guy has left me, Magic Jack for example, that's voice over IP as it's called, voice over internet protocol. That's part of this convergence of voice. If you watch Netflix or movies on the internet, YouTube, that's video. And then of course if you send an email or look at a web page, that would be data. Telepresence is a fun thing. It's being somewhere where you're not. Skype. And that is chapter 6. Hope you've enjoyed.